Today we're going to do Unit 4, Day 8 on equivalent representations, and we're going to do another slideshow. And in fact, this should feel very familiar to the slideshow you did last week. The questions are very, very similar, except we now are able to represent them with more complicated equations and do a little bit more math, especially with the work around slope, and be able to just go a little bit further. So this should feel very familiar, and I hope that it won't take you too long to do these. All right, so our first example is going to be our traditional example. The cost is $10 to get in the fare and $3 per ride. So we know I've been referring back to this example all the time because it's a great example of the types of functions and relationships that we're studying. So what I'd like you to do is do a table of this information, an equation, a graph, answer a couple of questions about it, and then do a little bit of math on this. And this is the step that's going a bit further. All right. Also, one big difference between these ones and the ones that we did before, the ones we did before were all direct variations, meaning they all started at 0. These ones are not, or they may be, but they are could be direct or partial. All right. So in this example, $10 to get in, $3 per ride. So we're going to start by saying, obviously, if 0 rides, costs us still $10 just to get in. And then at $3 per ride after that, so we can go up by 3s, 22, and 25. We can check that last one. 5 times 3 is $15 for the rides, plus $10 to get in is 25. And so our equation, we can go in and put 3, let's say R for rides plus 10. Now you could actually probably get that equation right from the statement, but you remember last day we did lots of connections between tables and equations. So if you are able to fill out the equation or the table, you can get the equation, or maybe you can get the equation first and then fill out the table. Let's check. This says the slope is 3. It's going up by 3s, and this is going up by 3s. And our initial rate is $10. All right, so we're going to take the dots like we did before and plot them on this graph. So 0 is going to be $10. 1 is 13, and you're going to have to just try your best on these. I know the dots are a little finicky. So 2 and 16 is just above. 3 and 19, so just below there. Should probably be just up a little bit. 4 and 22. And 5 and 25. That one's right on there. Okay. Now, in order to do the graph again, you're going to need to decide which arrow you're going to use, either a solid arrow or a dashed arrow. And in this case, it will decide whether it's continuous or discrete. And the number of rides is a discrete situation. Remember, you can't go on half a ride. And so we're going to have to choose the dotted arrow. So I'm just going to go and grab this. Oh, whenever you do something like I just did, don't just push Control Z. So I'm just going to grab that and put it at 10. And this is just working out there. Feel free to fast forward through this part. Here we go. All right. Now, you'll notice I'm okay if when you do your graphs, it's a little bit off from there. I know it's a little finicky, but you definitely get the idea of that graph. All right. So we've represented this with table, graph, and equation. We can answer a little stuff about this. Is this a positive or negative correlation? Well, it's positive because as the rides increase, the cost increases. Make sure we spell positive right. Direct or partial. So the ones we did before were all direct. These are going to be partial because there's a flat rate in this. And then we just already decided that this was discrete. Let's answer those questions right in there. Our last little part then is to do a little bit of algebra on this stuff. So what is the cost for 12 rides? So we could follow the pattern along, but that's inefficient. And we could follow this graph, but it goes off the graph. So we want to be able to use algebra to do this. So we're going to go in, and if R is now 12, we're going to substitute that into the equation. So it used to be 3 times r. So we're going to type in 3 times 12 plus 10. Okay? And then we can actually do that math. So I'll just pull up my calculator here. 3 times 12 is 36. Okay, so 36 plus 10, and I can do that, is 46. So the cost for this is $46, and you can delete that line that I gave you. All right, so the cost is $46. Now, the next question is the opposite one. If I give you a certain amount of money, how many rides can you get for that money? So we're still going to use this equation, but this time we don't know the r, we know the c. So you're going to start by putting in 55 at the beginning. That's the cost. And we'll say 3r, because we don't know what r is, plus 10. So this is coming right from the equation, but we're substituting in the cost now. Now, there's the 55 equals 3r plus 10. Algebra reminds us we got to isolate for the 3r, which means we have to get rid of this 10. So that means we're going to subtract 10 from both sides. That's why I have this red thing there for you to help you with that subtraction. Oops. Minus, there we go, minus 10. And then over here, we've got a minus 10 as well. You can put some spaces in there, and you should get your minus 10. All right, so that's just, I put that in there to help you with that first algebra step. We have to subtract 10 from both sides. So when I have 55, and I subtract 10, that leaves me with $45, which is just reserved for the number of rides. And now we have to divide both sides by 3, remember, to get r by itself. Right? We had $55, we'd taken off the $10 entrance fee, we got $45 left, we have to divide that by 3. So here's how I'm going to ask you to do the divide. You highlight the 45 and just go up and push underline. That'll put a line underneath it. Underline. Okay, and that'll look like your divide side. And again, you see I've left a space with a red number there, so you're going to be dividing by 3. Go over here and put 3. Okay, put your cases there. So that's purposely there on 3 to show the operations you're doing. And then we can go and check this out. 45 divided by 3, and we get 15. So 15 is r. Now you can go off and answer this question. For $55, you get 15 rides. Okay? So I know this is a little finicky, but I've tried my best to allow you to show your math in these steps. Good to do a little refresher of algebra here and a little algebra there. Okay? So what you're going to do now is replicate this for 3 other scenarios. So this second one is a cost is $10 per hour for a snowboard lesson and a $40 lift ticket. So there's going to be an initial start of 40, and then you'll do some math on that. The third is a reception hall, charges $20 per person for dinner and a $100 rental fee. So at a wedding or something like that, it costs that, but your dinner, so you're going to have to do that. You'll notice this one, they are going up by 50s here. So be careful when you calculate your costs. It's not 0 people, 1 person, 2 people, 3 people. It's going up by 50s, right? But your cost per person is your slope, and so that will help your equation. And again, answer these questions and 75 people for $3,000. And finally, an interesting one about Morgan has $600 in the bank, and she takes out $50 per week. So think about what this graph, I can tell you this graph is going to be a little bit different, and the slope is going to be slightly different when you do example 4. Okay, so there are your examples. I will now post these on, you can actually go and click on the slideshow. The first one will be done for you, and you can fill in the last 4, and then remember to just push turn in. All right, best of luck with this, and have a great weekend.